If we got multiple resistors in a circuit, we could reduce the number of resistors by finding the equivalent resistance, and from there we can apply Ohm's law and find the current or whatever we want, right? Yeah. But what if we have some complicated circuits like these two? In the first one, two resistors are connected from this point. We have a bridge, right? Yeah, it's kind of complicated, right? Yeah. The second one, we have like multiple voltage sources. So using the standard method would be a bit difficult here in these cases. So we're going to use a different method to solve problems with such circuits. Single loop circuits. That's our topic for today. So single loop, starting from this point, we're coming back to the same point. That's a loop, right? And in this circuit, we have only a single loop, right? So how do you find the current and voltage in the circuit? Let's call them R1, R2, V1, and V2. We're going to apply Kirchhoff's laws here. I'm going to write 4 steps that we will follow to solve such circuits. Step number 1, assign a direction for the current. Assign a direction for the current. Current flows from positive terminal to the negative terminal of the battery. If you have multiple batteries connected in a circuit, just follow the direction of the larger battery. But it's okay to be wrong in the first step. Even if you assign a wrong direction for the current, the answer you'll get at the end will be the same, except you'll have a negative sign. So it's fine. Okay, but try to get it right. Follow the direction of the larger battery. For example, if this is a 6-volt battery and this is a 8-volt battery, this is the larger battery, right? So choose this direction for the current. This is the direction of the current. If you choose the opposite direction, then you will get the same answer with a negative sign at the end for the current. Based on the direction of the current, mark the signs on the components. For a battery, it's easy. This is a battery. The longer terminal is positive and the shorter one is negative. Okay. So this is positive, this is negative. For this battery, this is positive and this is negative. For other components, current flows from positive to negative. So current is flowing up, right? This is the direction of the current. Current is flowing up. So this should be positive, this should be negative. Current flows from positive to negative. For R2, current is flowing to the right. That's the direction of the current. So this should be positive, should be negative. So for a resistor, depending on the direction of the current, the sign would change. If current is flowing to the right, this is positive, this is negative. If current is in the opposite direction, this is plus, this is minus. So current flows from plus to minus. That's how you mark the signs on the components. The third step is to choose a loop, either clockwise or counterclockwise. You can choose any loop, it's totally fine. The last step, using Kirchhoff's laws, write the equation and solve. So these are the 4 steps. First step is to assign a direction for the current. Second step is to mark the signs on the components based on the direction of the current. Third one, choose a loop, either clockwise or counterclockwise. The last one, using Kirchhoff's laws, write the equation and solve. Solve a problem. We have 2 voltage sources, V1 and V2. V1 equals 10 volt, V2 equals 3 volt. And 2 resistors as well. R1 equals 2 ohms and R2 equals 5 ohms. We're going to find the current in this circuit. The current flowing through R1, R2, V1 and V2. They'll be the same because it's a single loop, right? Yeah. Okay. The first step is to assign a direction for the current. So in this question, V1 is greater than V2. So follow the direction of V1. This is positive terminal, so current would flow from positive terminal of the battery to the negative terminal. Okay. Yeah. Back to the negative terminal. Okay. So that's the direction of the current. It's okay to choose the opposite direction as well, but your answer will have a negative sign. So that's the direction of the current. Now the second step is to mark the signs on the components. For battery, it's easy. This is plus, minus. This is plus, this is minus. Now, for R1, current is from right to left. So right is positive, left is negative. For R2, current is downwards. That's the direction of the current. So this should be plus, should be minus. That's how we assign the signs on the components. Yeah. Now the third step is to choose a loop. I'm going to choose clockwise loop. That's my loop. Okay. So I'm going to go clockwise in this loop. So don't get confused here. The direction of the loop has nothing to do with the direction of the current. The direction of the current is to mark the signs on the components, and we don't need it anymore. Okay. Now we're going to follow the direction of the loop. I'm going to go clockwise in this loop. Okay. So I'm going to write Kirchhoff's laws. So my loop is clockwise, right? So I'm going to start from here, from V1. You can start from any components, it's totally fine. But I'm starting from V1, okay? Yeah. So I'm going clockwise. So this is the direction I'm going. Okay, that's the clockwise direction, right? Yeah. Okay. I'm starting from here. So I'm going right. That is plus to minus, right? I'm going right in the loop. This is the clockwise loop. This is the clockwise loop. So I have to go right. But it's plus to minus, right? On the battery, it's plus to minus. So keep this in mind. If you're going plus to minus in a loop, that's a drop, right? Plus to minus is a drop. So you should put negative sign for the voltage. We're going to write Kirchhoff's voltage rule. So put a negative sign for the voltage of that component. I'm going right. That is plus to minus, which is a drop. V1 is the voltage. We should put a negative sign, minus V1. So we started from here. We're going clockwise. We are in the second battery now, right? Okay, it's minus to plus. Okay, minus to plus. We're going from negative to positive. That's a rise. So we should put a positive sign. Plus V2. So we started from V1. It's a drop. V2 is a rise. We're going. Okay, we are here now. Negative to positive. That's a rise. Minus to plus. That's a rise. So plus voltage across this resistor. Let's call it VR2. Okay, voltage across resistor R2. And voltage across resistor R1, let's call it VR1. In R2, we are going from negative to positive. That's a hike. So plus VR2. Plus VR2. V1, V2, VR2, VR1. It's negative to positive. That's a hike again. Plus VR1. We are back at V1, right? So that's all. And according to Kirchhoff's voltage rule, total voltage in a loop should be equal to 0. Now what is VR2? VR2. Voltage across R2, according to Ohm's law, it should be the current flowing through resistor R2 times the resistance. That is I times R2. I'm going to replace VR2 with IR2. Minus V1 plus V2 plus IR2. What about R1? Voltage across R1. Current flowing through R1 times current flowing through R1 is I, and resistance of R1 is 2. Plus IR1 equals 0. Okay. V1 is 10. Minus 10 plus V2 is 3 plus IR2. I is unknown. R2 is 5 plus I is unknown again. R1 is 2. equals 0. Solve for I. Minus 10 plus 3 is minus 7 plus 5i plus 2i equals 0. 7i equals 7, I equals 1 ohms. Another question, solve problem 6.1, charging a battery. A 12-volt battery with internal resistance Ri equals 0.2 ohms is being charged by a battery charger that is capable of delivering a current of magnitude I equals 6 amps. What is the minimum EMF the battery charger must supply to be able to charge the battery? So we've got a circuit diagram here, and there are two batteries. This is the first battery. It has an internal resistance of 0.2 ohms. And this is our second battery, VE. VE is the external battery that is used to charge VT. The question is to find VE. What is VE? That's the question. Ri is 0.2 ohms. VT is 12 volt. Current flowing through the circuit is 6 amps. So this is a single loop circuit. We can apply Kirchhoff's laws, Kirchhoff's voltage rule to solve for VE. The first step is to choose the direction for the current. VE should be the larger battery here because it is being used to charge VT. So I'm following the direction of VE counterclockwise. That's the direction of current in the circuit. The second step is to mark the signs on the components. For this battery, this is negative, this is positive, positive, negative. Current is flowing downwards, plus, minus. The third step is to choose a loop. I'm choosing clockwise loop. You can go for counterclockwise as well, no issues. L. I'm going to write Kirchhoff's voltage rule for this loop. We're going clockwise, right? So this is my loop. I'm starting from VE. That's my loop. Starting from VE, so plus to minus is a drop, so minus VE. Minus VE, minus to plus is a rise. So plus VT, plus VT, minus to plus is a rise again. So plus IRI, voltage rule, right? So we need to find voltage. V equals IR, voltage across resistor Ri should be equal to current flowing through Ri times resistance Ri, that is IRI. Minus to plus is plus voltage across Ri, that is I current times Ri. Yeah, that's the whole loop. We are back at VE equals 0. Solve for VE from here. So VE equals VT plus IRI. VT is 12 volt plus I is 6, Ri is 0.2. That is equal to 12 plus 1.2, 13.2 volts.